Okay, short example that isn't a fluid mechanics example, it's actually a physics, and this is we're going to use dimensional analysis on the period of a simple pendulum. So, period, it swings back and forth. Remember what period is, it's time to complete the revolution. So, I'm going to draw it as a funky T to not get mixed up with our time. So the period is T, and that is a function of, well, we look at the problem and we say, probably has to do with this length and the mass, and since it's swinging up and down, probably acceleration of gravity, so just say G here. So let's go through our process. We have this function, period is a function of, and let's just spread these out, L, M, G. Okay, I'm not going to go through in the detail I went through the last one. Period is time. It's easy enough. Length is length. Nice. Mass is mass. And G, remember, it's meters per second squared, feet per second squared, so that's going to be LT to the minus 2. This is a nice simple problem. Okay, so what we want to do first is look at the right-hand side, choose one of the dimensions, L, M, or T. I am going to pick L this time. You could have picked M or T. And then choose a variable that contains that. Well, L is the simplest one. Okay, so now let's go ahead and rewrite that. Well, we don't have to do anything with the left-hand side and L because there's no L in it. Okay, so just leave it alone. And, well, this is going to be L over L, so it's going to be gone. Okay, M we also don't have to do anything with because there's no L in it. G, just divide by L. And what we're going to have is T to minus 2 when we do that, right? Okay, so like I said, this is a nice easy one. Next, we want to get rid of, oops, forgot to write M here. Okay, we want to get rid of either T or M. I'm going to choose M and little m. Well, again, there's no M on the left-hand side, so T, still got a T under it. F, we've already gotten rid of the L over L. Now we're going to get rid of M over M here. Gone. And again, no M in this, so G over L still, and T to the minus 2. All right, down to just one variable now, so let's move on. Okay, all we have left is T. Okay, so we got to choose T, and we got to choose G over L as our term with T. Okay, now this is where the exponents get a little bit more complicated than what we had before. So we want to get rid of this T over on the left-hand side. Okay, so for our period, right now we have a T, and we need to basically multiply by T to the minus 1 to get rid of that. Okay, but what we got here is a T to the minus 2. Okay, so what we need to do is remember your exponent rules. You take that to the 1/2 power and multiply it by this, and you're going to get it. So it's going to be G over L to the 1/2. Okay, and what you get is T to the minus 1 there, right? If you do that, and those will now cancel. Okay, and then that equals on the right-hand side, well, we're using G over L. So G over L over G over L. Ooh, that's weird. That's gone. Okay, so basically what we're going to end up here with is T times the square root of G over L equals the function of no variables. Function of nothing. Okay, which means it must be a constant if it's a function of nothing. Call that C. Okay, so rearranging then, we're going to get T, not putting in non-dimensional, but just rearranging. We're going to get T equals C times the square root of L over G. If we're stopping, if we're doing the non-dimensional, we have our non-dimensional on the left equals constant. That's done. Okay, but let's just rearrange it to see what we get. We get t equals a constant times square root of L over G. Okay, all we need here, since this came out to be a constant, is one experiment. One experiment. And what that one experiment will do will give us C. And so we get t equals 2 pi. C turns out to be 2 pi square root of L over G. Okay? Or we could use physics and figure that out. Cool thing about that, when it came down to a constant like that, we have the whole equation. We can see what happens if we double the length. What do you think happens when we double the length? Well, double the length, you're going to have a square root of 2. So t goes up by square root of 2. Okay, so you can get more information out of this stuff sometimes than just scale modeling or experiments. Okay, that's it. So go ahead and finish the quiz. See you in